Assalamualaikum warahmatullahi wabarakatuh. Welcome back to my video in Chemical Environmental by Mochammad Choirurroziqin. Material to be explained. 1. Water and water analysis. 2. Contamination and analysis water. 3. Reagent contamination. Water and water analysis. In water and water analysis, sampling is collection a certain volume of a water body to be studied with a small amount, but representative and all the same characteristic as the water body. Sampling division. 1. Representative sampling. 2. Transport and preservation of sample. 3. Analyze the chemistry of the sample. In water and water analysis, preparation of sampling. First, the bottle used to take the sample must be cleaned and rinsed with distilled water, and then processed with the liquid that will be used to fill the water. Second, the tools used for sampling must be clean and not contain traces of the previous sample. Third, contamination of soluble metal in the sample line is prevented. Fourth, iron, brass, and bronze are soluble in acid or basic water. Meanwhile, rubber can be dissolved in industrial water. 5. Sample can be taken separately. Tools used to take sample. 1. Suction pipe. 2. Pump. 3. Hose. 4. In-bottle sample divider. 5. Box isothermic. Maybe that's all from what I got. Hopeful, useful, and say thank you. Uh, material. Next material. Contamination and analysis water. Contamination and analysis water. Contamination is the entry of unwanted compounds into the sample, and there are atmospheric contaminants. There are small particles that fly around and add to the concentration. Maybe how to overcome it so that we are safe or can protect. In human skin, contain metal even though their concentration are very low. Tools to reduce contamination: masks, gloves, and closed shoes, so that when we work we are safe. Here, plastic is a material that can cause contamination. A lot of plastic is contaminated with polymer, and there is contamination from water, namely by the amount that is reacted rather than the reactant. So next, last material. 3. Reagent contamination. In reagent contamination, the reagent contamination itself is divided in 1. Mineral acid and ammonia. 2. Inorganic solid. 3. Organic reagent. 4. Organic solvent. Inorganic organs and organic solvent are distinguished because the reagent comes from the drug region, while the solvent comes from the organic solvent. A. Mineral acid. Most mineral acids contain a certain amount of metal too. Extra pure acids contain metal in very low levels. Generally, reagents with this quality have a fairly expensive price. Ultra pure generally contain fairly low metal concentration, but the content of some elements varies from product to product. Analytical reagent grade acid usually contain metal as listed in the table. For the purpose of ultra trace analysis, this acid can be purified by distillation. B. Ammonia. Ammonia solution in water placed in a glass bottle will be contaminated by silica, aluminum, calcium, and other elements might be caused by attack alkaline solution on the glass. Analytical reagent. Ammonia can contain heavy metals in very low concentration. Zn Zn less than 0.005 ppm, Pb equally 0.003 ppm, Cu 0 point equally 0.005 0.2 ppm. This this is probably due to the absorption of the metal by the glass. C. Inorganic solid. Inorganic solids with reagent quality are usually sufficient for direct use without pre-purification, but a blank control solution must be prepared. Lead or Pb is an important metal. This metal content is usually found in solid KCl, sodium chloride, NH4NO3, and KNO3 analytical reagent ranging from 0.1 0.3 ppm. Purification usually by crystallization or filtration. Next, the organic reagent. In organic selecting reagent usually contain a coordinately bonded metal. This metal usually derived from the solvent or reagent used in the synthesis of ligands. Concentration expressed in ppm. TD zone. Zn 1.2, Fe less than 7, Cu equally 0.4 ppm. Coferon. Cn equally 7, Fe less than 0.6, Cu equally 0.16. Ethyl thiocarbamate sodium. Zn equally 0.04, Fe less than 0.6. Phenol fluoroacetone. Zn equally for 0.3. Fe equally 11.3. Sb equally 0.006. Cr equally 0.2. Ax equally 0.2. Cu equally 0.02. Hydroxyquinoline equally Zn less than 0.1 Fe 0 Fe equally 1. Uh, A. Organic solvent. Metal content in organic solvent is usually relative low, relatively low, which must be watched out for is the presence of other organic compounds dissolved in the solvent because it usually interferes with spectrometric determination. For example, CCl4 and CHCl3, if left unhacked, will produce COCl2, a sodium result, which will interfere with the determination of metal by Dittison method. F. Loss of analyte. At the preparation stage, the separation and determination of the analyte can be obtained from the sample solution by the following factor: 1. Adsorption, 2. Volatilization, 3. Co-precipitation or settling. Okay, and quotes of the day: all science can be achieved. There are no word to complete science. There is no worship higher than praying and seeking knowledge. Okay, see you. Assalamualaikum warahmatullahi wabarakatuh.